Hi and welcome to Gaffy's Grinds. It's great to have you here. If it's your first time to visit the channel, then you're very welcome. And if you're returning, it's great to have you back. This is video 3 in our module on electricity for junior cycle science. And as always, we are taking concepts from junior cycle science, breaking them down, trying to make them simple and easy to understand. And then we're doing lots of practice to make sure you guys actually learn it. So just the usual warnings. If you haven't watched video 1 and 2, it's a good idea to go and watch them first before you watch video 3, because they're done in order. Try and eliminate any distractions that might overload your working memory, which is very limited. Everybody's working memory is very limited. It's what we're using to listen and process all the things that are happening around us right now. So we want to just try and make sure we're focused on our the video here. So do that by sticking your phone on do not disturb, or even better, turn it off. Stick it in another room where you're not going to be tempted to pick it up. And the last thing is that I'm going to be asking you to do practice tasks and questions. If you don't do these questions and practice tasks, then you're wasting your time watching the video. You're just not going to learn very much. If you do the things I ask you to do, I promise you'll learn lots of stuff. All right, so with that in mind, this channel is all about retrieval practice, which means that we do lots of retrieving information from previous lessons and lots of practice on what we're doing today. So before we begin today's lesson, I've got some retrieval questions from the last 2 topics that are related to what we're doing today. So from memory now, I don't want you to go back and look at what you did in your notes or your questions the last day. We're trying to do these from memory, see do we still remember them. So I want you to answer these questions now 1 to 8 as best as you can using full sentence answers. And if you really don't have a clue, just skip it and get to the end, and then you can maybe go and have a look back at what you did the last day. But try and just get to the end first, okay? So do this in your own time now. Pause the video and do the questions. Okay, so you should only be watching the video now if you have tried questions 1 to 8. And if you weren't able to do any, maybe you went and had a quick look back at last day's stuff, and that might have jogged your memory. Right, the answers are coming up. I'm not going to spend too long talking about these because these are already what we did the last day. So charge, what is it? Then a coulomb, what is a coulomb? It's a number and it's equal to 6 quintillion. We use it to count electrons. Charges of the subatomic particles, which are protons, neutrons, and electrons, and there are the charges. Again, that stuff should be straightforward. Stuff we learned the last day then. What unit is used to measure current? It's measured in amps. Current, what is current then? Current is a measurement of how quickly the coulombs of charged particles, which is usually electrons, are moving in a circuit. What unit is potential difference measured in? We measure in volts. Again, I'm hoping you guys remember this stuff from the last day. If not, maybe you need to go back and watch the previous video. If they have a wire, what do they need to do to make it a circuit? Okay, so a student attaches a battery to a long piece of wire. What do they need to do to the wire before it's an electric circuit? They need to make it into a loop, a closed loop, so that the electrons can flow around the circuit. And the last one then, what is the purpose of an electric circuit? What is the whole point of an electric circuit? Well, the point of an electric circuit is to transfer energy to the surroundings. So transfer energy from inside the circuit to the surroundings. So we can take that energy that's stored in our battery or the energy that's coming into our homes in the mains from the national grid, and we can transfer that energy to the outside of the circuit and the surroundings, which is usually our homes or our devices. We do this by putting different devices into the circuit. So into the looped wire, we do this by putting different devices. So that's what today's lesson is about. It's about learning some of these devices and how we draw them, okay? We are building our way up to drawing full circuits, but before we're going to be able to draw a full circuit properly, we're going to have to know how we draw the different components and the different devices. So as you see here, I have a table with 16 boxes, and I have a name and symbol in the first one, and then I'm going to begin by drawing them. Now, the way this is going to work, guys, is I don't want you frantically trying to copy what I'm doing. I want you to watch, listen while I explain each one and what it does. After I've drawn a few of them, I'm going to stop. I'm going to hide what I've drawn, and then you're going to try and draw them from memory. So really do be paying attention, okay? Right, so the first device that we're going to learn about is a cell, what we call a cell. So we draw a cell like this. Okay, we've got this bit here. This is a wire. So anytime you see one of these straight lines in these devices, that means it's a wire. And we've got a long terminal, which is always on the left. We've then got a short terminal on the right, and the wire continues like this. Okay, so we've got a wire, then a long terminal, then a short terminal, and a wire again. So the long terminal is always on the left, and it is the positive terminal. The short terminal then is always on the right, and it is the negative terminal. So this is a cell. Now the job of the cell is to push electrons around the circuit. That's what it does. It pushes electrons around the circuit. It stores energy. There's a lot of energy in the chemical energy stored of a cell. That's what it is. We learned that the last day. And it does chemical reactions. When the chemical reactions happen inside the cell, it pushes the electrons around the circuit. So that is a cell. This is a battery. A battery is just two or more cells combined end to end. So here is one cell, and here is a second cell. So we've got positive and negative here, and then we've got another positive and negative here. So two cells shown end to end like that. Now it could be 3, it could be 4. It's just like the toys you had when you were a kid. Some toys took two batteries, some took 3 batteries, some took 4 batteries, and so on. The more batteries you put into something, the more cells you're going to put into it. So a battery is just more than one cell. Okay, 2 or more cells, and they're connected end to end. This here is a wire with a switch in it, but I am showing this switch is open. So this is the switch, but it's an open switch. As you can see here, this gap means that the switch is not closed, it's open. So we've got a wire, an open switch, and then another wire, and the switch is open, and this means this stops the current from flowing around the circuit because we do not have a closed loop when the switch is open. Okay, so this so what I'm going to do now is I'm going to hide what I've done, and as you can see here, I've got the table down below. So what I want you to do is I want you to pause the video. I want you to start to draw out that table. Leave yourself enough room in the boxes to draw the devices, and I just want you to do the top row. What have we just the 3 that we've just done? So you can draw out the table. You can put in headings if you like, and then I just want you to draw the top 3. Pause the video now. Okay, so you should only be watching the video again if you have drawn out this table, you've put the labels in, and you have drawn the first 3. Let's check to see if you got them right. So the cell, the battery, and the switch that's open. This is what you should have. Check yours now. Okay, so that is what you should have. Okay, well done if you got that right. If not, then make some changes. I should have said actually that you should draw these in pencil, and then they're easier to fix if you make a mistake. So if you weren't already doing that, draw the next ones in pencil. Apologize, I should have said that earlier. Right, the next one we're going to talk about is similar to the one we just did, except we have a wire, and then we have a switch, but this switch is closed. So now the switch has been closed. This keeps the circuit connected and allows the current to flow. So there's no break in the circuit when the switch is closed. So this is a switch which is closed, or a closed switch. The switch closed. Okay, the next thing we're going to do is we've got a wire, and then we're going to draw a circle, and then the wire continues. And into that wire, we're going to draw an X, like this. This is a filament bulb or a filament lamp. Filament bulb or filament lamp. Now, the filament in the bulb gives out light because it is heated by an electric circuit by an electric current. As the electric current passes through, The filament is made of a very thin piece of wire, very thin, much thinner than the wires that's carrying the current. So when the current passes through this really thin wire, it heats it up because the resistance is quite high. So it heats it up and that causes it to glow, and it glows really hot and that gives out light. So a filament bulb gives out light when it is heated by an electric current. That's how it works. So that is a filament bulb. These are like the old types of bulbs that you would have had in your house before the new LED type. So the old non-energy saver bulbs, those ones, the ones that might feel very hot when they get when they're turned on. The reason for that is the filament has to get really hot to give out light. LEDs work differently now, so they don't have to get as hot. So that's the filament lamp, and it gives out light as it is. The filament is heated by an electric current. The next one I'm going to draw is a wire with a circle again, and the wire continues. And inside the wire, I'm writing a capital A. This is the symbol for what we call an ammeter. An ammeter. An ammeter measures current in the units of amps. So we put this into the circuit, somewhere in the circuit, and it will measure the current. So it counts the coulombs of electrons going past. That's basically what it does. And it gives you a reading for current in the units of amps. This is an ammeter. The next thing I'm drawing is a wire with a circle, and the wire continues. But in this one, I am putting a capital V. A capital V. This is a voltmeter. And we can use this to measure the potential difference in the circuit in the units of volts. So a voltmeter measures potential difference in the units of volts. Okay, so again, I'm going to hide what I've done, and you're going to do the second line. So drawing the switch closed, the filament lamp, the filament bulb, the ammeter, and the voltmeter. So pause the video and draw them now. Okay, so you should only be watching the video again if you have tried to draw the 4 symbols on the second line. The switch closed, the filament lamp, the ammeter, and the voltmeter. This is what you should have. Let's check yours. Okay, so at this stage, you should either put a little tick beside them like this, in red maybe, just a little tick in the corner so you'll know it's right. And if not, rub it out and fix it so it's correct. Okay, so you should have a little tick like this for each one. And that'll let you know when you're going back over them that you did have them right. Okay, the next line, onto the next line. I am drawing a wire that connects to a long rectangle like this, and then the wire continues. This is what we call a resistor. This is the symbol for a resistor. And a resistor is a device which limits the flow of the current. So we learned in the last lesson what resistance was. Resistance is where the current gets restricted, or the current gets slowed down. So that's what a resistor does. It slows down the flow of the current, or it limits the flow of the current. For this type of resistor, the resistance is fixed, which means it does not change. So if you put this into a circuit, it will always have the same resistance. So it might have a resistance of 10 ohms. So you can have a 10 ohm resistor. And if you put that into the circuit, it will always create a resistance of 10 ohms. You can buy a different resistor, which is 100 ohms, and that will, again, have a fixed resistance of 100 ohms. So you can't change the resistance unless you change the resistor. The next one I'm drawing is very similar to the resistor. It's a wire connected to a rectangle and then connected to a wire again. But this one has a diagonal line, or a diagonal arrow, starting on the left and going up towards the right. So bottom left corner up to the top right corner, passing through the rectangle. This is a variable resistor. Variable resistor. So it's still a resistor like the first one. It limits the flow of current, but however, the resistance can be changed for this one because it is variable. So this is a variable resistor. So this one you can set to either, 10 ohms. You can turn it up. Then it's got a little twisty knob on it that you can turn up the resistance. So you can start it at low at 1 ohm. You can turn it up to 10 ohms. You can turn it up to 100 ohms. So it's just a resistor that you can change the resistance of. The next one is, this time the wire continues the whole way through. There is a rectangle. So I'm drawing a wire. I'm drawing a rectangle around it, but the wire continues through the rectangle. This is the symbol of a fuse. This is a fuse. Now, if there is a problem in the circuit, such as too much current comes in, a lot of times this might happen if there's a lightning strike, for example. The lightning would add current into it would add extra current into a circuit if it, hits a wire near your home or something like that, and that would send extra current into your house. So if there's too much current, or if there's another problem in the circuit, what happens is the wire inside the fuse will melt, and that causes this wire to melt, which means you've got your electric wire connected to the edge and you've got it continuing at the edge, but now the wire inside the fuse has melted, and that means that the circuit is no longer complete. So by breaking the circuit, the fuse stops the current from flowing. Current will only flow if we've got a full circuit. So a fuse is essentially a safety device that cuts off the circuit if there's a problem. So the proper diagram for it again is, we have the rectangle and we have a wire that continues through the fuse. Okay, so if that wire melts, then it cuts off the circuit. The next one is a wire connected to, again, what looks like a resistor. So we've got a rectangle in the circuit, but this time you've got kind of like a hockey stick looking thing that goes, so it goes from left to right, a straight line here, then it goes diagonally through the resistor. This is what we call a thermistor. A thermistor. And the job of a thermistor is that it's sensitive to temperature. It's sensitive to temperature. So it has a high resistance at low temperature, and it has a low resistance at high temperature. I'll repeat that. It has a high resistance at low temperature. So when the temperature is cold, when it's cold, it restricts the flow of electrons. So it reduces the current when the temperature is low. When the temperature is high, it does the opposite. It lets the current flow. Its resistance is low when the temperature is high. So this allows us to use temperature to control a circuit. It allows us to use temperature to control a circuit. That is a thermistor. Okay, so you are going to do the next three for me. Okay, so pause the video now, or the next four, sorry, pause the video and do the ones in line 3 here: resistor, variable resistor, fuse, and thermistor. So pause the video and do that now. Okay, this is what you should have had. Again, check that they're correct, tick them if you got them right, or else rub them out and fix them if you got them wrong. Right, there are 4 more devices that I want to tell you about. Okay, this one I'm going to draw is I'm drawing a line, and around the line I'm drawing a circle. Oh, I'm not very happy with that. Just going to get rid of that circle and draw it again. Okay, and in the circle, I'm going to draw a triangle which points to the right. Sorry, that's not a great triangle. It's a triangle which points to the right, and then there's a little line like this. Okay, so it's a circle, and inside the circle, we've got an arrow that points to the right, and then there's a little line. Now, what this is this is a diode. A diode, D-I-O-D-E, diode. And the job of the diode is it allows electric current to flow in one direction only. And you can think of this triangle actually as being like an arrow. It's pointing to the right, points to the right. and that's the direction that it lets the current flow. So it lets the current flow from left to right here. If I twisted it around and put it in the opposite direction, then it would allow the current to flow in the other direction from right to left. But it allows it to flow only in one direction. It will not allow it to flow backwards. It would not allow it to flow backwards. That is a diode. The next one is similar to a diode. I'm going to draw a similar thing again. I'm going to draw a diode like this. I've got the triangle or the arrow pointing to the right again. But this time I've got two little arrows in the top right corner pointing away from the diode. Sorry, they're not great now. I'm just going to try and draw them again. Oh, sorry, no. Just get rid of them. Okay, so I'm just going to draw them a little bit better. Okay, you've got two little arrows pointing out of the diode in the top right corner. This is what we call an LED. LED. And this stands for light emitting diode. A light emitting diode. If you think about what that means, light emitting, giving out. So emitting means giving out. Light, so giving out light, and it's a diode. So it's a diode that gives out light. So the function of an LED is that it gives out light when electric current passes through it in one direction only. So same as the diode before, this diode would only allow current to flow in the same direction as the arrow here. So it only allows current to flow in that direction. When current does flow through it in that direction, it gives out light. And LEDs can come in many different colors, loads of different colors, red ones, yellow ones, blue ones, green ones. Most devices now with any kind of colored lights on them are LEDs. Plenty of the bulbs in your home now as well are LEDs. They're just white LEDs. Okay, so that is a light emitting diode. The next one is I'm going to draw a wire, and I'm just going to draw a wire completely actually. So from right to left. I'm then going to put a resistor in the middle of it. So there is my rectangle for my resistor. And I'm going to put a circle around like this. And then I'm going to draw two little arrows going in at the top left corner. These are going in. So notice different from the LED. Those arrows went out at the top right corner. These arrows are going in at the top left corner. This is an LDR. And an LDR is a light dependent resistor. So a light dependent resistor is sensitive to light. So when the light is strong, what we call high light intensity, so when it's very bright, this resistor has a low resistance. And when the light is low, or when it gets darker, it has a high resistance. So this allows us to use light to control the circuit. So that's the light dependent resistor. Again, when the light intensity is high, it has a low resistance. So when it's bright outside, the resistor has a low resistance and it lets the current flow. When it gets darker, it has a high resistance and it slows down the current. That's a light dependent resistor. The last one I'm going to draw is a wire and a circle. And inside the circle is a capital M. This is a motor. This is a motor. And the function of the motor is to spin or to move or to turn when electric current passes through it. So when you put this into a circuit, it's able to take the energy that's in the circuit and it converts it to kinetic energy. Okay, so it converts it to kinetic energy and it starts to spin around. And that's able to transfer energy then to the surroundings. So take, for example, a battery-powered fan. So the circuit goes from the battery to the motor, of the fan. So the battery to the motor of the fan, and then once the motor starts to spin, the blades of your fan will spin and you can hold it up and you can cool yourself down. So that's possible. You are transferring that energy from inside the circuit in the batteries to the motor, and then we're able to use it then. So that's the whole point of an electric circuit, is for us to be able to use them. Okay, time for you to do the last 4 now. Okay, so let's pause the video and try to do the diode, the LED, the LDR, and the motor. Okay, so you should only be watching the video again now if you have drawn those 4 devices. So let's have a look. Here are those 4 devices or components: the diode, the LED, the LDR, and the motor. Now I just want to make sure that, you know, these red lines are just for me to tell you about, to highlight something. They're not part of the diagram. So just want to make that clear, like that. Okay, that's what you should have. All right, now it's time to do some practice on that stuff now. So what I have for you here is I have a fill in the gaps paragraph. So this is the reason I'm giving you this is it helps us to improve our scientific writing. So what I would like you to do now is I would like you to pause the video and I would like you to write this paragraph out, but trying to fill in the gaps. Okay, so don't just write the missing words, write out the whole paragraph. It's good practice to learn how to write properly in science. See, so pause the video now and have a go at that. Okay, so this is what you should have. The answers are coming up. So again, you should only be looking if you have actually tried to do all of that. All right, so make sure you've had a good go at it, and this is what you should have. So the gaps or the answers will be shown here, highlighted in yellow. Pause the video and make any corrections. Okay, so you should only be continuing the video now if you have tried it and you have corrected it and you have corrected any mistakes. Okay, got some questions to practice now. Okay, so what I want you to do is I want you to pause the video and have a go at questions 1 to 13, please. Questions 1 to 13. Okay, and you should only be watching the video, playing the video, if you had a go at questions 1 to 13. And here are your answers. Questions 1 to 13. This is what you should have. Check your answers now, please. Sorry, just 1 to 13 there. You don't have to do number 14. Pause the video and make any corrections now, please. Okay, so that's it for today's video. Okay, in the next video, we're gonna practice putting those components together to make a circuit. And we're gonna take a look at a simulation to help us have a look at trying to have a play around at trying to build circuits. Okay, so I'll see you in the next video.